Hi, my name is Fraser and welcome to Graphic Card Repairs. So today we have a Zotac Twin Edge 3060. Now the issue with this card is that it does not get detected and there is no fan spin. So what I feel is that there might be an issue with the trace. It might have a broken trace. That is, if it's like one of those cards that I've repaired in the past, where Zotac cards they burn out the trace. So for this particular issue, we will open up the card and we will know once we open it. So before we do that, let's take some resistance measurements. To start with, let's start with the 12-volt PCIe, and we don't have a short. 3.3 volts, and we don't have a short. Let's check the 8 pin, and we don't have a short. Okay, so what we'll do is we will open up the card. Let me take out the screws. So Zotac has, in the past at least, Zotac has a trend where it burns out a trace because one of the capacitors, shorts itself. If this is one of those particular cards, then it's a very simple fix. But if it's not, then we will, know what exactly the issue here is. So let's open it up. So I have already repaired 7 cards where the traces were burnt, and because this card doesn't have any fuses on the board. Okay. Okay. There you go. Okay, this one is a bit tricky. Let me just give it an assist. Okay, it's out. Okay, I'll take off the back cover as well. Now, the thing about this particular card is that there are no thermal pads at the back, so the back really doesn't make any contact. So I don't know, if I don't think the heat really is transferred onto the back plate. So it's just there for protection and not for heat transfer. It would be nice if Zotac had to put in some thermal pads, so it would be nicer to dissipate the heat that's generated at the back. It's not that this card heats up a lot. It's just that something that would make it a lot more better or a lot more cooler than what really is right now. Okay, let me just take a look at the most obvious suspect. Let me switch you on under the microscope. Okay, so this is where normally you would find a broken trace, but I don't see any broken trace right now. Okay, let's take a look at the rest of the board. Let's take some resistance measurements. Let's see if we have a short on this 12-volt line, and we don't. So it looks like that is not the problem. So the problem is something else, which we will have to find out. Let me check this capacitor. So normally in those cards, one of these two capacitors blow out and causes the trace to break. But in this card or in this particular scenario, it's not the case. Let's scan the back surface. Okay. So over here, it looks like some kind of watermark, or there's some damage that has been caused by water or something. So we will come back to this. For now, I'll just make a note of it. You can see around the resistor, there's a lot of corrosion, and on this resistor as well. So there's a lot of corrosion. So I don't know if it's making proper contact, or it could be the cause of the problem, but we will come back to this. We'll take a look at the rest of the card. But it either looks broken or something. I'm not too sure. I don't know if it's making contact or broken, but let's come back to that. So looking at the front now. So the front looks okay. There's nothing that I see. Is there anything here? Let's take a look at RAM temperature. The resistance, and it's 30 ohms. That's fine. Let me just try and get this. Just a second. I'll remove this thermal pad, and let's see what's the memory that's underneath here. I'm suspecting it's Samsung. Yes, it is. Okay, so the resistance is fine. 30 ohms is okay. There's it's exactly what it's supposed to be. Let's scan the rest of the area there. So I don't see anything wrong in the front except for the watermark here, where there is some kind of corrosion there. I'm not too sure. Let's check. Okay, I'm getting a reading of 24 kilo ohms, and this one looks to be an open line. It's not making a proper contact. Okay, so what I'm going to do now is I'm just going to connect the power and see which are the voltages that we have missing. So once we check the voltages, so we will have a clue as to where to start. Okay, first what I'm going to do is I'll just check what is the kind of power draw. So I will know if there's anything wrong. So I'm going to turn it on. And you can see it's just pulling 0.02 amps, which is very low. So it's just like it's not doing anything at all. Let's check the rest. So I'm just going to go in reverse. Let me check the 12 volts PCIe. Let me turn it on, and we have 12 volts. Let me check PEX. I know what you're thinking, that why are you checking PEX first? So I'm just going in reverse. 1.8. We don't have 1.8. And let me see, 5 volts, and we don't have 5 volts. Let's take a look under the microscope. So if we don't have 5 volts, we don't have anything except for the 12 volts and 3.3 volts. There's nothing else that we will have. So this is the inductor, and it's driven by this particular chip. So that's the chip, and this inductor is driven by this chip. Let's take a look at what we have on this chip. This is pin 1, and I'm supposed to have 0.8 volts, and I have nothing. Pin 2, it should have 12 volts. Nothing. We have 12 volts. That is pin 5, and I have 5. I'm supposed to have 5, and I have 5. Pin 6 is enable, and I have only 0.6. Pin 7 should have 5 volts. I have nothing. Pin 8 has nothing as well. So we don't have enable, and what I mean when I say we don't have enable, it's just 0.6. Enable should be about 2 volts, so 2.3 to 2.5 or 2.6. Okay, let's take a look at pin 5 again. And now I have only 1.5. Enable, I have 0.8. So it looks like it's fluctuating. So I'm supposed to have 5 volts, and it's just all over the place. Okay, so this is a chip that is responsible for the enable signal. Let me just clean this a bit. So it's a dual transistor that sends the enable signal to enable 5 volts. And we had corrosion there. Let me just clean it a little more. Okay, it looks better. Just a little bit of more of alcohol. So I don't know, it's really making contact there because earlier those two resistors were showing like, as if they were corroded. Let's zoom in a bit. So really can't make out if it's making contact. But okay. Okay, so just to give you an update as to what exactly I have done now, just to uh, give you an update. Now, there was corrosion over here on these two resistors. It could be there was some water damage or something, and these resistors when I removed were not showing proper. So this resistor was showing about 25 mega ohms, whereas it's supposed to be a 10K resistor. So what I've done is I've gone ahead and replaced this particular resistor because one side is 12 volts. Same here on this resistor as well. This is a 24K resistor. I've replaced that resistor. So from this chip, I'm supposed to get 2.3 to 2.6 volts, which is the enable signal. So I've gone ahead and replaced both these resistors so that now after the replacement, we are going to go ahead and check if we have our enable signal coming from this chip. So our main culprit was these two resistors. Let's take a look if we have our signal now. So let me switch to the other view while I connect the power supply. There you go. We have our 8-pin connected. So we will now check if we have our you know 5 volts since we've gone ahead and replaced those two resistors. Turning it on. And we have our 5 volts and our power consumption is 1.2 amps, which is exactly what we require. Okay, so looks like we had our enable signal missing. The reason we didn't have the enable signal is because of those two resistors. Okay, and we have our resistance. Let's take a look at the rest of the voltages. Let's take a look at 1.8. We do have 1.8 PEX. We do have PEX as well, and memory. We have memory. Let's take a look at the core. We have core as well. So we have all the voltages that are required. So what I'm going to do is I'm going to assemble this card. Let me just clean this card a bit and assemble it, and we'll take a look from there. Okay, so I have assembled the card and put it on the bench. Let's check if we can get any image. Turning it on now. And we have a picture. So the card is detected and the fans are spinning as it should. Let me quickly try and boot to the correct drive. There you go. So I'll quickly load into Windows, and we'll just run a couple of stress tests. So I'm not going to run any memory diagnostics because there was no issue with the memory. It's just that this particular card wasn't getting detected. So I'll just wait for the drivers to load. Let me open Device Manager. So when I first received the card, I was assuming that it might be one of those cards where the traces have burned. So I was a little bit, you know, in fact, I wanted to make a video on that, but it's only after I opened the card that I, knew that that's not the case. But it's okay. We do receive cards, with different issues. So what I try and do is I try and make a video on every different issue that I get. So, my viewers can learn uh, or refer to my videos whenever they wish to. So a bit of a background about this user. Okay, there you go. The drivers have loaded. Done. Okay, a little bit update about this user. So this user has traveled all the way from Oman to Dubai. So that's about 6.5 hours drive, and he traveled all the way from there. And once this card is fixed, he's going to go back. So this repair has taken me approximately about 3.5 hours, and it's this card is working. I'm glad that I could deliver the card back to him, within a short time frame, because he has to travel back 6.5 hours back to Oman. Let's run a small test. Only heavens. There you go. And I don't see any kind of artifacts. Let's keep a watch on the temperatures. The temperatures looks fine to me. I don't see any spikes or anything. So we are done for this video. That's about it. I hope you like this video. If you liked it, please hit the like button and comment and share. And make sure that I respond to almost every comment. So thank you and have a good day. Bye for now.